Evaluation metrics is an important interview topic because it tests whether you understand both the concept and the practical engineering reason it matters. Start with the plain definition. Evaluation metrics are how we decide whether a model is actually good for the task. Accuracy is simple, but it can be misleading when classes are imbalanced or when different mistakes have different costs. Classification often uses precision, recall, F1 score, ROC AUC, PR AUC, and confusion matrices. Regression often uses mean absolute error, mean squared error, root mean squared error, and R-squared. For generative AI, evaluation includes human preference, factuality, toxicity, latency, cost, and task-specific success. In interviews, start with the business goal, then choose metrics that match the cost of errors. A strong answer should not rush through this. The goal is to make the listener feel the problem first, then introduce the tool. For this topic, the headline is, Choosing the Right Score for ML Model Quality. Say that in your own words, then connect it to a realistic machine learning system. Ask what the model is trying to do, what can go wrong, and why this idea helps. That framing makes the answer sound grounded instead of memorized. Now slow down on the core idea. The main points are, accuracy can hide class imbalance, precision asks, when positive, how often right, recall asks, how many positives did we find, F1 balances precision and recall, metric choice should match real-world cost. Think of these as the 5 anchors of the explanation. Do not just list them. For each one, say what it means and why it matters. If you are explaining this to an interview, move from intuition to mechanism. First describe the simple mental picture. Then explain how the system actually uses it. Then give a small example. The example can be abstract, but it should be concrete enough that the listener can follow the flow. This is where many short answers fail. They name the concept but never show how it behaves inside a real model or pipeline. The mental model or formula for this topic is F1 equals 2 times precision times recall, precision plus recall. Treat the formula as a compression of the idea, not as the whole answer. Walk through each part slowly. Explain what the inputs are, what gets transformed, and what output we care about. Then connect the symbols back to intuition. If someone forgets the exact notation, they should still remember the flow. In an interview, this is powerful because it shows that you understand the math operationally. You are not just reciting an equation. You can describe what each term does, what changes when it is too large or too small, and how the formula affects model behavior. Next, explain the trade-offs. The practical trade-offs are, optimizing one metric can hurt another, threshold choice changes precision and recall, offline metrics may not match user value, production needs monitoring after launch. This is the part that makes the answer sound senior. In machine learning, almost every technique buys one thing by spending another thing, speed versus accuracy, flexibility versus complexity, training performance versus generalization, or simplicity versus capacity. Say what the technique improves, then say what risk it introduces. Also mention when it might fail. A good answer includes the sentence, I would verify this with validation data, production metrics, or a targeted experiment. That shows engineering judgment instead of theory alone. For the interview checklist, make sure you cover these points, ask what error is costly, use confusion matrix intuition, define precision and recall, mention threshold tuning, connect metrics to deployment monitoring. A clean structure is definition, intuition, mechanism, trade-off, and example. If you get nervous, return to that structure. Define the term in one sentence. Give a mental picture. Name the important formula or pipeline step. Explain what can go wrong. Then say how you would measure or debug it. This pattern works especially well for AI topics because it balances concept knowledge with real implementation awareness. It also prevents vague answers like it improves performance, because you always explain which performance and under what condition. The crisp summary is this: evaluation metrics should be explained as a concept, a mechanism, and a trade-off. Start with choosing the right score for ML model quality. Then use the formula or flow, F1 equals 2 times precision times recall, precision plus recall, to make it precise. Finally, connect it to practice, what you would measure, what you would tune, and what failure modes you would watch for. If you can do those 3 things, your answer will feel complete. You will sound like someone who can use the idea in a real system, not just recognize it in a textbook. That is the standard we want for these longer videos.